This is Pongurali from IT Department, Sri Shanmuga College of Engineering and Technology. I am going to present a topic stacking data structures using C. Let's begin. Stacks. Stack. The stack editor. Generally, first let's see stack. About stack. Stack, that is nothing but it's a list in which insertion and deletions can be performed in only one position called the top. Stack is a linear structure which follows last and first time. Then the fundamental operation performed on a stack are push operation and pop operation. The first one is push operation, second one is pop operation. The push operation, which is equivalent to inserting an element, that is called as push. So let's begin. Here consider like a part. So this is, we are using fields. 3 fields we are here. First field, second field and third field. First, when we want to insert one element to this field, that is B. So B is the first element we have insert in this box. And A is the second element we have to insert the box. And C is the last element we have to insert in the box. So this process, when we insert in a particular system, this scenario is called as the push operations. That is, which is equivalent to inserting an element, it's called as the push operation. Push operation. Okay, so then this is next one is the pop operation, which is delete the most recently inserted element. Let's be consider another one box. Similarly, so we are here, we are having 3 elements. One is B and another one is A and the third element is C. So there are 3 elements we are inserting already. So this operation is we know as the push operation. Here we have specified here. And similarly, the another operation is pop operation. Pop operation means which deletes the most recently inserted element. Here the most recently inserted element is C. So here itself C is, we can delete, that is operation is called as pop operation. That means, for example, stack of coins, stack of pancakes. So this is the process called as, this is push operation and this is pop operation. Generally, so pop of S and top of S and stack. Similarly, push X of S, that is input operation, and pop operation, that is output operation. The top of the stack denotes the most recently inserted element, and the pop and the empty stack is generally considered as an error. Okay, so next, the implementation of stacks. So that is the implementation of stack using arrays and stack implementation using pointers. There are 2 implementations by using stacks. One is implementation using arrays and another one is implementation using pointers. Okay, and operations, array implementation of stacks. What are the operations are performed in the array implementation means, that is, first one is creating a stack, second one is inserting an element onto the stack, and third deleting an element from the stack, and next checking which element is at the top of the stack. So these are all the operation array implementation of stack. So next, creating a stack. So when we have to create a stack, the stack is capable of storing size number of elements. The first element will be at position stack 0. The last element is position at size -1. So here define size 10, that means structure stack, the open brace and int s of size into top and close brace s. So this is the main of the creating stack process. And next, stack empty operation. When a stack is created, it is empty and top is initialized to 1. So before inserting or deleting elements into the stack, it is necessary to find out whether a stack is empty or not. So that is initially integer I is empty. So that is open and close brace. If s of top w equal to -1, then return 1, else return 0. That is, if the stack is empty, it will return the value until 1. Next, stack full operation. So, to insert an element into the stack, it is necessary to check whether the stack is full or not. If it is full, then the element cannot be inserted. So, int is full, the open, if s of top is equal to size minus 1 and return 1, else return 0. If the stack is full, this function will return the value 1. And push. So, push is a function which inserts new element at the top of the stack. To push an element x onto a stack, top pointer is incremented and then stack top is equal to x. The function as follows: void push integer x and stack s. So if is full of s, so error full stack overflow. Else top is equal to top plus 1 and s of top is equal to x. This is closed to last position. And pop. To pop element, the stack top value is returned and top pointer is decremented. Here, the void pop stack of s, if is empty of s, error, the empty and stack underflow, else. So, x is equal to s top, top is equal to top minus 1, return x. And that's all. When return top element of the stock and making empty stock. These two incidents only we are finally discussed here. One is int top element stack of s. That means if the exclamatory is empty of s, return s top. Else error empty stack, return 0. This is over. And void make empty stack of s and s top is equal to minus 1 and close brace. So for making empty stack, we are using this scenario, and return top element on the stack, we are using this kind of uh, return stack coding. Okay, so that's all. This is the return top element of stock and making empty stock, and that's all. Over. Thank you.